Okay, I'm going to finish up chapter 7 now. 7.7 is the last section that we're covering, and we're talking about these. Let's see, the product to sum and sum to product formulas. Here's the formulas in that group in this section. So I'll be referring to those for different examples here. We'll get right to it. So we'll find in this problem, I want us to find the exact value. Now I've got a product, and I don't know what sine of 285 degrees or cosine of 195 degrees is the exact number, because neither one of these angles are common angles. Okay, so if I were to use the product to sum formula, which I'm doing here, and let's see, it's actually this third one in the group that I'm using. So 1/2 times sine of, supposed to be subtracting the angles, 285 minus 195 is 90, and then plus sine of, I'm going to be adding the angles, 285 plus 195 is 480 degrees. And, okay, sine of 90 degrees is 1. Sine of 480 degrees, well, 480 degrees, that'd be the same as 360 degrees plus 120 degrees, right? And a 480 degree angle would be the same angle as a 120 degree angle. It would put me at the same radial line as a 120 degree angle. Sine of 120 degrees, let's see, so that'd be a 60 degree angle, but it'd be in quadrant 2. The opposite side is root 3. Hypotenuse is 2. Root 3 over 2 is what I got there, and here'd be the exact number then for when you multiply. Okay, part B, we want to find the exact value of sine of 75 degrees plus sine of 15 degrees. Well, I don't know either one of these because, again, these are not common angles. And so, of course, if I were to go to a calculator, I would get some decimal form, some infinite decimal. That's not going to help me. I need the exact value, which means that the idea is that we'd like to refer to the trig identity sheet here. Okay, so I'm going to be using the sum to product formulas. Let's see here. I'm adding two expressions involving the sine function there, so I'll be using this formula here. It's going to be 2 times sine of, you'll add the angles and divide by 2. 75 degrees plus 15 degrees is 90 degrees. Divided by 2, that's 45 degrees. Times cosine of, subtract the angles and divide by 2. Okay, 75 degrees minus 15 degrees is 60 degrees. Divided by 2 would be 30 degrees. And the good thing about using that formula is because now I've produced common angles. Sine of 45 degrees, that's 1 over root 2. And cosine of 30 degrees, that would be root 3 over 2 when I build my triangles there. These 2's will cancel. Root 3 divided by root 2, if you rationalize the denominator, that'd be the same as root 6 over 2 then, and that'd be the exact answer. Okay, here's another one. Write sine of 3 theta times sine of 5 theta as a sum containing only sines or only cosines. Okay, well, I've got a product here since I'm multiplying. I want to write it as a sum, so of course I'll be wanting to use my product to sum formula, the first one here. So sine of alpha times sine beta, that'd be 1/2 times cosine of, I'm subtracting the angles, 3 theta minus 5 theta is negative 2 theta. And then minus cosine of, I'm going to be adding the angles, 3 theta and 5 plus 5 theta would be 8 theta then. Okay. The cosine function is an even function, so cosine of negative 2 theta, that'd be the same as cosine 2 theta. And, you know, I want to give my answer here so that the angle is a positive, looks better. Okay, here's another example. Write sine of theta over 2 minus sine of 3 theta over 2 as the product of sines and or cosines. So right now we've got a difference, right, or a sum. We want to write it as a product. So I'll be using my sum to product formula. Let's see here. I'm subtracting two sine expressions, so I'll be using this formula. Sine alpha minus sine beta is 2 sine of subtract the angles and divide by 2. Okay, that'd be negative 2 theta over 2 is negative theta, and then divided by 2 times cosine, add the angles and divide by 2, so that'd be theta over 2 plus 3 theta over 2 is 4 theta over 2, or 2 theta. Divided by 2 would be theta. Sine of negative theta over 2, that's the same as negative sine of theta over 2. The sine function is an odd function. And so it's typical to give the answers, without negative angles. That's how the book will be doing it. All right, and yeah, so there's my product then. My last example, we're going to establish an identity. So, okay, we'll start with the side that is more involved here, which is obviously the left side, and we got to get to the right side. Cosine of theta minus cosine of 3 theta. Let's use the sum to product formula. It'd be the last one here. That's negative 2 times sine of, I'll have to add the angles and divide by 2. Theta plus 3 theta is 4 theta, divided by 2 is 2 theta, times sine of, subtract the angles and divide by 2. Theta minus 3 theta is negative 2 theta, divided by 2 is negative theta. And then in the denominator, I will also want to use my sum to product formula. It's going to be this guy here, the second one. We'll want 2 times sine of, subtract the angles and divide by 2. 3 theta minus theta is 2 theta, divided by 2 would be theta, times cosine of, add the angles and divide by 2. It's going to be 3 theta plus theta is 4 theta, divided by 2 would be 2 theta. Sine of negative theta is the same as negative sine of theta. Negative times negative is positive. So that allows me to then cancel the 2's and then the sine theta terms. And now I'm looking at sine 2 theta over cosine 2 theta. Well, that would be tangent of 2 theta then, which is what I had to get to there on the right side. Okay, so that's all there is in Chapter 7. Hopefully that's enough for you there. And the homework in 7.7 is on page 515. Be sure to look at those for me.